Hello and welcome to the GitLab Runner Implementation Best Practices Review for LevelUp. In this short video, I'm going to run through the scope of what I'm covering, then what best practices means in this presentation, and cover briefly shared and specific runners. The presentation focuses on the runner and server dynamics and doesn't delve into the workflow enabled by the runners. Best practices is a term that's been used to imply the things everyone should be doing. This presentation talks about the benefits of certain things, but there are partial and incremental approaches that can work very well. It's not an all or nothing thing. The most important aspects are that you do any sort of shared runner fleet. The best way to get a shared runner fleet is to focus on containerization of jobs. And if you have containerization in a shared fleet, you can take advantage of auto scaling for the high performance, low cost. Now let's talk about how. First, we'll talk about shared runners. These are provided as part of the GitLab.com experience. Organizations who self-host or bring their own runners will need to hear this part. In this section, we're going to cover shared runners. Shared runners in GitLab terminology are registered across the whole instance. Some organizations have multiple distinct teams in the same instance, kind of like a multi-tenancy situation. If you have group runners that are registered at that first root group, it can provide a similar experience. We'll cover the benefits, the constraints, and some executor types that do well with shared runners. There are many benefits to a shared runner pool. The most important is that users don't have to do anything to have real-time feedback on the work that they're doing. Auto DevOps can build whatever's in a repo and show whether it builds or not. Additionally, with containerization, users can explore custom images. They can design as many tiny images as they need. These typically are used for things like deployment. If you have kubectl or Helm, building software with Go or Maven, even a static site generator like Hugo, linting and code quality scanning, other kind of meta-analysis of the source code itself can be done in containers. The list goes on. Even wrapping a small shell script in a container turns it into a reusable artifact that can be used on multiple projects. And another huge benefit is end-to-end testing capability, where you can have a runner fire up the project application container and then add background services. These services can be a database memory things. It could also be other custom containers that are built alongside the main one as like a microservice architecture. We even have one test job that uses services to create an entire K3s instance to test our Kubernetes API calls. There are some constraints that come with these shared runners. The first is that the runner is scoped to the whole instance. It will pick up jobs from any project anywhere on the system. This needs to be deliberately configured since all users have access to the runner pool. To provide wide-ranging but still limited shared runners, the instance can have a few top-level groups that define teams for billing or security boundaries. Adding runners to those groups can provide a shared runner capability without allowing disruption between the groups. The other major constraint is that the whole pattern relies on containerization, which I consider to be a good constraint since it motivates modernization efforts. One reason it helps with modernization is that the ingredients are simple. It's just bash and Dockerfile. From these two technologies, any sort of job can be designed and run without needing plugins or a DevOps team to build out custom DSL scripts. Keep in mind that container constraint, the job running the build and deployment needs to be containerized. The content generated can be a jar file. It can run in a WebSphere app or some long-running IIS environment, or it could be a static site that's served from an S3 bucket. The jobs themselves just have to be containerized. Shared runners should always be a containerized type of executor. The current best options for that are the Docker and Kubernetes executors. For large-scale Docker executors, the Docker machine type provides isolation and scalability, and it can be tuned to your organization's needs. For .com, we have tuned it all the way toward isolation. So there's a single build per VM. This is very expensive, but it's necessary for security reasons. If you have a friendly group of users working in the same area, you can configure it to reuse the VMs and save a lot of time and use caching and other benefits. Specific runners are always bring your own runner. Any project or group owner or maintainer can register runners for those scopes. In this section, we're going to cover specific runners. Specific runners in GitLab are registered only to a project, similarly to the broadly registered group runners, mimicking a shared runner. Registering a group runner against a small group that only has a couple of projects in it mimics the specific runner. Let's explore those benefits and constraints, as well as executors. The benefits to a specific runner come from the flexibility of having a tightly coupled runner to project relationship. Tight coupling is not a best practice, but if it enables a team to use automation, it's a fine intermediate step. Developer teams can control the scope of the project and runner, so they can improve their own workflow without increasing any coordination expenses. This is especially beneficial in legacy environments, where a lot of time is spent on getting a build environment to be just right. You have to have proper tools and libraries, maybe an old version of Windows or Linux or Java. Like, set it up once, register the runner, and you're good to start automating things. This also allows like .NET framework applications to run through an automated build test and even deployment steps in a CI fashion without having to refactor the whole thing into .NET Core or re-architecting it. Additionally, emulators and hardware, if you attach it to a runner-enabled system, can be configured to install and test firmware. There are only a few constraints on specific runners, most of which are on the organization implementing them. Users need to be trusted to install and maintain their own runners. The responsibility is on the users to stay up to date and maintain security on their repositories to keep the runners functional and secure. A DevOps team trying to coordinate and control all the specific runners across an entire instance will turn into a bottleneck from having so many little minor tasks and tweaks to do. There's a risk that legacy applications will adopt the bare minimum of CI using a shell executor of some sort, and then stop progressing. Taking follow-on steps to add to the containerized jobs for quality, security, other sorts of deployment things, those may end up being delayed because they were able to take some steps without having to move the whole application in a different direction. Certain keywords in the pipeline are also ignored for shell runners, which are the most common specific runner type. So the pipeline won't be able to run, it won't be able to use an image, it won't be able to run services, and they don't really auto scale. There's kind of a way to do it, but it's typically not warranted to take on that much overhead. All executor types are reasonable to configure as specific runners for a group or project, depending on what the group or project is doing. Even Docker and Kubernetes can be attached to smaller scopes. These may be required to support something like runners in a specific network or virtual private cloud, or with access to certain data via an NFS mount or something like that, or a variety of other reasons. GitLab's open nature provides several places to find out more. The docs have pages for general CI practices and pipeline definition reference, which is a great doc to see all the functionality. The company direction page tells you about what's coming in the future for the CI team. And then we also have the GitLab projects open to the public to follow along if you want to watch the GitLab-runner project or the CI-CD group. It's full of interesting projects. Thanks for taking the time to watch the presentation.